then I'm pushing F5. It's no longer registered, which is kind of cool. That's not working. Where is it on slideshow? Aha!
Yay.
Hey, so sorry to keep everyone waiting. We're only 35 minutes late. I just would like to thank Stu for inviting me to present. In particular, about something that I know relatively little about. So I'm not like the world's greatest Erlang programmer, but I've been noticing that there are a bunch of extremely big systems which rely on it, and it's been really intriguing because there are a bunch of them that have used Python in a bunch of interesting ways. So in terms of sort of an outline for the talk, I thought I could just explain some of those motivations in slightly more depth, and then give a couple of examples of where there's been a bit of a synergy, or at least I've seen some synergies between those two products, and maybe pull out some lessons. And then if everyone is feeling keen and they have their laptops, I actually thought we can get people into groups of 4 or 5, which is quite convenient given that you're all in groups of 4 or 5 already, to see if you can have a bit of a code war or something. Now, okay, so like, why did I decide? Can everyone read these slides, by the way? That's useful. So, yeah, I did this idea of sort of bringing 2 language communities together just sort of seemed quite odd and interesting and quirky, and I had some spare time over the weekend, so I thought it would be worthwhile to look at. For me personally, I have wanted to use, say, React and CouchDB properly, and so I thought that at some future state or some future date there might be some utility in actually learning how to get the most out of the systems themselves. This is where we're going to spend the bulk of the talk really today. And has anyone used CouchDB before? Okay, so we're going to be starting with, CouchDB is what they call a document database. That means the structure or the schema of data is actually fixed inside individual records rather than in, say, a table or a relation, depending on your terminology. Which means that you can be extremely flexible as a programmer or an application programmer, because all you have to do is keep things as broad as you like them. Or you can expand and contract things. You can have arrays, which are actually quite tricky if you're not used to sort of SQL as query language. The downside is querying the data. CouchDB doesn't provide you with really many tools. It provides you with one tool called MapReduce. What it will promise you, has anyone encountered the MapReduce programming paradigm? So the idea about map, and if you've ever played in with Python's functional tools, you'll recognize the map and reduce functions. So does anyone want to say what the map function does?
Run a function against every item in an iterable?
Yeah, so if I have a function and a list, and I apply, map will apply that function to every item in the list and pump out the new list as a result. And that's what the first part of map is. Now what's reduce? Does anyone have a concise way of explaining what the reduce function is? Okay, so here's an attempt. If I have a function and another list, at the end, what I will get back is a single result. So I've reduced a list all the way down to sort of typically a scalar value. So I might have a list of integers, and I would like to sum the result. So what reduce is receiving is a function, sum, and then it starts at 0, or it starts at the first item on the list, and then just goes on to the next item. And then if you just apply that some function again and again and again and again, eventually you'll get to one result. Now, CouchDB does this in a way that enables you to retrieve or extract things by key. So you might have like, typically it would be like person dash identifier, or you'll attempt to, it's sort of irrelevant for this discussion actually, but it's quite an interesting programming paradigm that you are attempting to create these lists of things and associate keys and values. And now to do that, you have these things called view servers, and in CouchDB they can be applied in any language. So all you do is give Couch an executable, and Couch will just write to standard out and expect responses in standard in. And in fact, it even serializes functions in the database itself as strings and sends those to the view server. The database itself doesn't actually know what the data is that it's even got inside it. It's all, so the database, it doesn't really care. It just says, dear view server, please provide me with data that is going to be useful to me. And the data that's useful to Couch is JSON. JSON is a serialization format that was very prominent in that came out of JavaScript, and Couch was kind of the first database to say, you know, that is going to be how we represent data, because it is understood by everyone, and in particular when they come to these query or these client, if we want to provide a client interface and things are already encoded as JavaScript values, it means that building a client database over HTTP is going to be extremely simple. Everything is HTTP, everything is sort of JSON, which means that there's this database built for the web. Now, the interesting thing I thought about when I was thinking is that this first one just uses standard in and standard out, so it's sort of this black box executable. CouchDB, because of Erlang, its Erlang roots, is also going to be a web server as well, and so it can also just talk these protocols, even if they might be inefficient. You know, a database designer wants to keep the messages as short as they can and wants to minimize any deserialization and so forth. Couch said, you know what, it really doesn't matter. Our computers are fast enough to actually figure that out. And HTTP, if you've ever looked under the covers, is a really inefficient protocol. But it's well understood, and it does what it's told to. Has anyone encountered the Disco project? What about Hadoop? Okay, so Hadoop is a really, really big project that enables you to, as they say, kind of analyze petabytes of data. And it does this through that MapReduce paradigm. It will say, and it was initially built at Yahoo for analyzing things like web pages. You know, how many words are in it, which pages link to which pages, to actually build up the graph for their index. And the reason why it is a useful thing to do this, to process data in this MapReduce paradigm, is because the data can be split up in as many ways as you have computers for. So you can distribute the data across dozens and dozens and dozens, or thousands and thousands and thousands of computers and commodity disks. And in fact, you don't even need to worry if they fall over. Hadoop makes a promise to actually keep things alive for you. Disco does the same thing, only it's written in Erlang and uses Python as the programming language to implement what they call mappers and reducers. So you can do the programming in a sort of quite more familiar or easier language. The Hadoop project was originally just Java-based. There are some abstraction layers, or there have been other query languages built on top of it subsequently. But when it was originally created, the really only way you could work with it was by understanding a bunch of relatively arcane Java APIs. So you can think of Disco as kind of a more lightweight alternative to a really big project. In Hadoop itself was supposed to be a really light alternative to some of these really huge data mining packages, or much, much, much cheaper than, say, your Oracle standard database, or SAP, or some other very expensive commercial products. Now, React is another database. Oh, so what is interesting about the transport and the protocols? Erlang has this thing where it has a way of building applications called OTP, which provides a supervision hierarchy. So if anything at the bottom falls over, or if there's an exception sort of low down in the program, say in a specific function call, that function will blow up, it'll throw an exception, and it'll say, I'm dead, and then, but the program won't halt. The application itself will resist failure. What happens is there is a process, what in Erlang terminology is called a process, which is supervising all of the worker bees. And if a worker bee dies, it will just spawn a new one. Or it will undertake some behavior that is defined by the programmer. And why that's useful is, say you're building a message bus, or say you're building something, and you might get in some corrupt data, or something that's actually a corner case. You've got a parser, or you're building something that's receiving data, but someone sends you something dangerous. Now, you don't want the whole system to die. If you're telecom and Erlang is running in all of your base stations across Africa, you still want the rest of the phone calls to go through, even if there's a problem with one of the phone calls or one of the text messages. If someone's trying to use your system in a malicious way, you don't want that user to impact everyone else. Erlang can treat any external process in the same way. So it can call an executable, and there's a binary protocol, and it just sends data. And as far as the Erlang world is concerned, I'm talking to quote a port. And and from the Python's perspective, it just looks like standard in and standard out. And I just think that's kind of neat. It means that this thing, Disco, doesn't actually care what the workers are doing. It just cares about getting messages and data to the right places. So this Disco project will make sure that if you've got petabytes of data, that it's not stored in one place, that it's spread out across, say, your whole cluster, all of its disks, and that the data that's over here is processed by the CPU that's closest. That's what Disco is promising you. It's not going to get in the way of telling you how to process your data. So, getting on to some new database systems, a couple of years after Couch was this thing called React. Has anyone encountered a content, I like talking about the heritage of these things. A React has anyone heard of that product? It's less well known, but it comes out of a company called Akamai, and Akamai was one of the first content delivery networks. If you've ever heard the term CDN for if you're doing any web stuff, the idea is that you distribute your static files around the world, and so that the server that is closest to your web client is the one that the internet browser is talking to. So for example, if I go to google.com, there's not just one Google server, they're distributed around the world, and there are certain bits of pieces that lots of applications share, like say jQuery is a really popular package. Now jQuery, along with HTTP, can say, actually I'm version 2.20, and if you go to one single CDN, the browser will pick up that address and recognize, oh, I've already got that, so I don't need to go and download it again. Akamai was one of the first companies to turn that idea into a product. And they did this with the origins of this thing called React, which provides extreme durability. The idea is we will be a little bit slower, but we will guarantee that your data will survive. And in fact, they have an open source package and a commercial one. The commercial one will actually ensure that data survives if things break within a whole data center. It's actually quite an incredible product. Now, to get data in and out, they do a very similar thing to Couch, but they've introduced a new serialization format called Google Protocol Buffers. And I just thought that was a new evolution. So we're trying to get a little bit closer to efficiency, even though we're trying to get something which is very programmer convenient. We're still providing HTTP and JSON as like the bulk of the way that we're transferring data. For anyone who has encountered Google Protocol Buffers, you write a little description file about what your data looks like. So I've got a message. I have, in React's case, an integer with a code, like like 9 might represent add data, or add a document to the database, or replicate. And then I'm just going to have some space. Now, this last one is probably where the odds are turned around. In all the other packages that we've got, Erlang has acted as the core, and Python has kind of either done the work or been closest to the programmer. In this last case, I'm talking about, has anyone encountered the Celery project? It's a queue-based system. You give it things to do, and tasks get done and later on. So in that case, Python is doing most of the work everywhere. It's just saying, Erlang, get my messages to where they need to be. And it uses this thing called RabbitMQ, or the Rabbit message queue, and it just prays that Rabbit will actually deliver any data to other Python parts of the program.
Sorry, is RabbitMQ an Erlang system?
Yes, it is. RabbitMQ is Erlang, and it's an implementation of this thing called the Advanced Message Queuing Protocol, which the original, so RabbitMQ is an implementation of this messaging protocol, and Celery uses it to distribute messages between your application and worker processes. And they can be distributed amongst several computers. So you could have a whole data center processing images, or doing analytics, or whatever else is useful to you as an application designer. Wrong way. So I just thought, like, what I was expecting when I was looking at the source codes of these projects to find like extremely intricate and really advanced ways of describing data. Couch, everything is in JSON. Like, they have a command here, and that might be delete, and then a document ID is the payload. And I just JSON strings in a JSON array and end with a new line character. Like, that's all there is. And in a little way, by about Monday, I was worried that I wouldn't even have anything to talk about because this was so simple. They just have like a 4 or 5 character command. And there's a length of the payload, and then it's separated by spaces. So they have these extremely simple, and protocol buffers, I thought it might be best if I write one, but effectively, effectively, you write this description file, and then they have an integer, and then a space for a string, and so it's this. It's just in a binary format, not a text format. Now, so what did I kind of get from this exploration? Well, simple beats speed, I think, is a, CPU's cycles are free is one way to look at it. That a lot of people are quite happy to serialize lots of data in JSON because it's well understood. And maybe that it's okay in a product to mix different languages. And in particular in the case of Disco, where you have a big company, Nokia Research, actually puts time and money into paying people to build a product that has merged 2 languages that come from quite different communities, really. And this one's a little harder to read, but I thought let's have a go at seeing if, as groups of 5, and I think we have a group here, we have one at the back, and we have a cluster of 3. If we could have a go at improving on this, so who here is like a relative Python, who here can interpret this? Maybe start, if we ignore this, and start at main. I can read through the code if you'd like, but it'd be interesting if it's intelligible to other people.
That makes sense.
Okay, so what am I aiming to do here?
A list of tasks that you want to execute.
Yeah. So I've got it. I'm defining some tasks, and then here I'm using a bit of Python magic. The globals function will return everything that's been defined in the global namespace, and then I'm actually going to filter that down and say